So yeah, and this is the one that you're probably familiar with. Ontologies of modern medicine, controlled vocabulary, or shared vocabularies, facilitating interoperability, the same song and dance we often give when we're selling ontologies. I won't try to sell it to you. Can you just give me the mic, man? This is maybe. How's that? Better? Very good. Okay, so in the AI and modern medicine, AI, I'm thinking broadly here, NLP, ML, semantic similarity, and as well as large language models. And as I'll talk about in the last portion of this, large language model specifically is glue between systems. I'll elaborate in just a second. But before I get there, so this is a paper in 2003, sort of late 2003 that was later, it was on archive, but it was later published and refined. But basically it outlined three broad ways in which knowledge graphs, or as the authors characterize them as ontologies with instance data, knowledge graphs, how they could be used to help support or interact or engage with large language models. And so you see we've got, they could help enhance large language models. They could help, large language models could help enhance or augment knowledge graphs, or there's some kind of synergy between the two. Broadly speaking, this is how, this is how a lot of literature has fallen out since. For example, looking over here, just knowledge graphs informing or enhancing large language models. I honestly just Googled or just typed into LLM. It was like, give me something within the past couple of months, because there's a whole bunch of literature that's just constantly pouring out on these topics. And so you see here's OntoTune, ontology-driven self-aligning or self-training for aligning large language models. Purpose being to enable generation of responses guided by the ontology. And so it's kind of tuning or aiming to tune large language models for more accuracy in given domains. So knowledge graph enhanced large language models for task-specific purposes. Over here in the middle, LLM augmented knowledge graphs. More broadly, knowledge graph or knowledge representation development or strategies. Right here, comparative analysis of ChatGPT for automated mapping of local medical terminologies to SNOMED. So embellishing and elaborating, enhancing SNOMED using large language models, mapping local medical terminologies into SNOMED. Of course, you see here, like I've also underlined the kind of typical challenges that one would expect and has come to expect in the limitation sections of all of these papers. But again, just illustrating that middle ground, that second option, right? LLMs enhancing knowledge representation. And then, of course, we have the synergy, LLMs and knowledge graphs, this nice little virtuous circle. Here's an example, uses of SNOMED CT and LLMs, a scoping review. Talks about all sorts of literature from 37 different studies, different types of literature to train corpora, to fuse models, integrating SNOMED CT, do entity extraction, typing classification, normalization, all in kind of a virtuous loop to both enhance the LLMs for tuning and expand the knowledge representation in SNOMED. So yeah, again, not going to spend too much time because I'd like to talk about something slightly different than all of these sorts of cases. It's partly because I think large language models, they're very attractive. They're easy to use. NLP integrated, like you can chat with it. We do it all the time. I know. I see. We all play with these things. Simplifying interactions, but the workflows that we're dealing with in practice, whether research or actually trying to do work, no offense, but actually trying to do work, it's a lot more complicated than just chatting with a bot. Like the workflows that we deal with are complex. We have specialized tooling that is not LLM ready. But people typically, and a lot of the literature typically focuses on just over-reliance on either just improving or trying to improve LLMs or just using LLMs to improve what we're doing. And they're not really, in my estimation, engaging with existing toolkits or finding a way to engage with LLMs in existing toolkits so we can take advantage of the virtues of previous generations right now with this awesome technology we have. And so this sort of spurred a paper that is going to come out in a Winter Sim conference in November that's focused on using large language models as middleware. And so instead of replacing specialized tooling and things like bioinformatics and healthcare, we leverage large language models to connect tooling in a larger ensemble or suite in a way that usually humans had to do. Usually humans had to sit there and manually think through how to connect this output from this tool over this output in that tool. The question again, of course, should arise: which languages as input, syntaxes as inputs to these tools do you need, and which tools should you pick? And that was a hard question. It's still a hard question. It's an open question, but we made some progress, me and some other folks. But note the paradigm that we're talking about is additional to this one. So it's specialized tooling in the mix as well. So not just these LLMs, brute force, and knowledge representation, but tooling as well throughout. So the general high-level idea, though, is using an LP or LLMs as a natural language way to both translate syntaxes and then interact with tools, which I think is the best use right now of large language models. Not to go like expand data. I don't trust it. It's good at translating syntaxes, though. They have refined rules that can help it do that. It's also very useful to interact with, easy to interact with. Use it as glue, as middleware between your specialized tooling. So natural language, LLM translator, drafting an OWL, Alloy, some formal verification tools if you want to run reasoning, or various simulation syntaxes. And then you can use the simulation tooling or the logical tooling that already exists to run reasoning, simulate, do state transition diagrams and whatnot. We leverage the tools that already exist, and we use the LLMs to integrate this stuff together. It should seem commonsensical, and yet, show me where people are doing this. I mean, I know where people are doing this, and it's usually in a commercial space because they have to get an ROI, and they know zero shot is not going to work. They're not going to be able to do what Alloy does, and they're already using Alloy, so how do they pull in new information, translate into appropriate syntax for Alloy, and then run Alloy? So I see them doing this. I don't see us doing this. But to make it easier, and here's the paper if you're interested, from over-reliance to smart integration using LLM as translators between specialized modeling and simulation tools. It's broader than that, though. We talked about a list, or gave a list in here of various tasks, modeling tasks that you might have, like merging modules or models, building models from a corpus of text, validating model structures. You have example languages or syntaxes. And then over here on the far right, we have a list of specialized tools that you might avail yourself of. Now, I literally do this. So this is not like a theoretical thing. Like if I will have it help me, I will write code or scripts that interact with the AI or whatever tooling I need, and then translate into different syntaxes, and then call through APIs tools like this. And I do it in a single workflow. I just push a button and I say, I want you to run all these tools. I don't want you to I don't want the chat GPT or various GPTs to do the reasoning. I want Hermit to do the reasoning, something like that. Also, you may still not be on board, so I thought I would put another table in, mapping out exactly the modeling workflows for you so that you can connect the tooling up to what you might want to do. So say you're like drafting initial model structures from natural language, recommended tooling for such a task. GPT-4 is pretty good. You also, Protégé might help you if you're doing some simulation and modeling tasks. You have UModel or ER Studio. Now, the LLM role here is just to translate textual input to structured representation. Again, I do this all the time. Like, it's actually pretty good at translating across syntaxes. Of course, I have to be there to check the semantics, but the syntax is easy. Let it do the easy part. Integration notes output should target tool compatible syntaxes like RDF XML. And you can use these tools, various tools to validate that syntax. So I actually don't need to spend that much time making sure the RDF is valid because the tool already does that. Same for model verification and logical enforcement. This is one I use a lot. So recommended tools, Alloy, Hermit, what are they? Shackle validators. These are useful. I find them very useful when I'm thinking formally about modeling phenomena. The LLM role here, I'm over here on the fourth from the top, converts informal constraints to formal rules and explains violations. So LLMs are not good at logic. They're terrible. They suck. And you can get them to say whatever you want, basically. Plenty of examples in my lectures if you want to go on GitHub and see. You can get them to say whatever about logic. They're kind of unmoored. But if you have some formalism in your character, or if you have some description of some domain, and you can explain it well, clearly enough, and that's on you. That's on you. Then it will write the syntax for you correctly for the most part. Of course, you don't have to go check and think very hard about whether the syntax is correct. You run it through the specialized tools to do that. And you check the outputs. Now, of course, think about what I'm saying. You still have to understand the logic. You still have to understand the outputs. It can't understand that for you, and you shouldn't trust it to. But I tell you this much. I save a lot of time using LLMs as glue, as middleware. And I work a lot faster. And I think there should be more research focused on that integration rather than trying to get these things to do reasoning they're not supposed to be developed for doing. It's kind of like a fool's errand, I think. So, but also one more time. So this is this business rule formalization. This is a good one because MIT recently came out with a study, and it was talking about lots and lots and lots of different applications of LLMs in business cases. And it said most of them were terrible. Most of them didn't really have a good ROI, except when you're thinking about like backroom business rules. They said that's the biggest ROI for companies. Like thinking about like they're very good at understanding business rules apparently. So this is good. So now there are also recommended tools that they can use. Various companies can use this using LLMs as middleware to connect to natural language prompting, people on the ground, customer service, chat, and then call the tool to help validate or verify. And what's going on is converting high-level requirements into constraint logic for the tool. And the tool can check things like completeness and syntax. And then you can also use the LLMs for traceability. Now, hopefully this should be commonsensical. So it should be obvious, right? Is it obvious? Yeah? Yeah? Are you doing this? Yeah? Do it. Do it. Save yourself some time. And if you want to learn how to do it, I'm teaching a seminar right now. Teaching a seminar right now where you poor souls who have decided to sign up, this is sort of what we're doing. I'm like walking you through using LLMs as tools, as middleware, with a whole suite of other resources that are very commonly used in ontology engineering circles. And so I would highly recommend you at least take a peek at that if you want to know some of the details.